Okay, what do you think we're going to be measuring with this formula? Hey, look at that. Pretty straightforward, right? We're going to be finding the distance between 2 points. Okay, now we're not going to start out looking at a graph. We'll get to the graphs maybe tomorrow or Monday, depending on how we do today. But this is the distance formula. What do you notice about this formula? It's long, right? It's confusing. It's kind of complicated. There's a lot going on. We've got a square root. We've got little 2's. We got up top 2's. We got little 1's, y's, x's, all kinds of crazy stuff going on. The distance formula is also up there on one of those posters on the far left side, second one down. And it's very scary when you first look at it, but it's really not that bad once we actually get some practice with it. So I understand if it's a little bit overwhelming. This is not the lesson you want to be on your Chromebook for. I'm letting you know that right now. So I would probably recommend closing it, okay? Even if you're a great multitasker, you should probably close that out because this can be confusing when you're getting started. Make sure everyone has 2 highlighters, a yellow and a pink for me real quick. That's how we're going to organize this information so it's a little bit easier for us to digest. Mentally digest, not digestively digest, okay?
I didn't know if you were really hungry today.
No, thankfully not. I'm hungry for knowledge, but that's about it.
What grade did you have in 7th grade, Mr.
A's.
F.
So that's so proud.
Just to answer the question.
What's the best?
I didn't say obviously I got A's. I just said I got A's. I got 1 B in math in 8th grade. And that was the only B I got in middle school.
I know. I think I had an F in math one time because the first day I didn't do something.
Well, what are you going to do? It's all right. It's all in the past. So, the distance formula, D stands for distance, obviously, and that's equal to the square root of this whole mess. So let's break down what this mess is. We've got the first quantity is x2 minus x1. Okay, we're going to highlight x2 in yellow. And we're going to highlight x1 in pink. So I'm doing x2 minus x1, and then I'm squaring that. Whatever I get when I subtract that, I'm going to square it. So x1 is the x-coordinate of the first point. That's what that little, it looks like an exponent, but it's on the bottom. You see what I mean? So that's not x squared, it's the second x value. Does that kind of make sense? No? Okay. So we're going to be looking at 2 points, right? Every point has an x and a y, an x and a y. Here's the first point, there's the second point. I've got my first x, my first y, my second x, my second y. It'll make sense. Let's just color code this here. So like I said, x1 is the x-coordinate of the first point. x2 is the x-coordinate of the second point. And we'll develop more context for this when we start looking at like maps and stuff. But we're just keeping it simple and, well, not simple, but strictly math today. And then I'm adding whatever that is to the quantity of y2 in yellow minus y1 in pink. And I'm squaring whatever that is as well. All right, now in this quantity, y1 is the y-coordinate of the first point, and y2 is the y-coordinate of the second point. So, one way that we can visualize this, I'm going to write it up here on the board real quick, is you guys ever use like the maps on your phone before?
Yeah.
And how it shows you the street view from like up above?
Yeah.
So let's say like here's a neighborhood, right? Here's your house right here. And then here's your friend's house down here. Okay, so like there's your house, there's your friend's house. Now there's roads going like this way, right? And there's roads going this way. And there's all these other houses in between if we're thinking about a neighborhood, right? So if this is my first point, right, it would have coordinates of x1, y1, right? Imagine this is a graph. It kind of looks like one anyway. And your friend, that's the second point, has the coordinates x2, y2. Everybody kind of understanding that so far? Is that kind of making sense? Okay. So, if I'm here, I'm at my house, I want to get to my friend's house, I can't just cut directly across this whole neighborhood in a straight line, right? I've got to go down the street, and I've got to go up the street, and now I'm at my friend's house. Do you guys know what I mean?
Yeah.
Okay, we've all been in a car before, right? Okay. So I can't just cut through because there's all these houses, all these yards. I can't just walk to my friend's house in a direct line. I've got to take a vertical distance, and then I've got to take a horizontal distance. What we're finding today, though, is the straight line distance from one point to the next point. Okay, so from your house to your friend's house, if I could walk in a direct line, how far is that, right? If you go on your maps and say, oh, how far is McDonald's? It'll tell you it's like a mile away. But the mile away is this distance plus this distance because that's the way I would drive. You know what I mean? When the direct distance from the two is actually closer. So that's kind of just like a context so that it makes a little bit of sense. We're actually going to look at graphs tomorrow and it'll make way more sense, which is why I said this can be a little confusing. So let's just see, what are we going to do? Let's say we want to find the distance between the points 3, 4 and 6, 8. Okay? 3, 4 is my first point. I'm going to highlight that point in pink. Because it's the first point listed. First point. In reality, it doesn't matter which point you call the first point and which point you call the second point, but we're just going to keep it consistent. 6, 8 obviously then must be my second point. Have you ever heard the phrase, like, getting from A to B? Like getting from one point to another? Here's point A, there's point B. I'm getting from A to B. All right? So, 3, 4. Between those two numbers, just looking at 3, 4, which of those numbers is my x coordinate? The 3 or the 4? The 3. How do I know that 3 is my x coordinate?
X comes before Y in the alphabet.
That's right. X comes before Y, just like in the alphabet. That's something we talked about months and months and months ago, so I'm glad you remember it. So, 3 is my x1. I'm going to highlight 3 in pink, and I'm going to call 3 my x1. So if 3 is my x coordinate for the first point, then 4 must be my what? My y coordinate for the first point.
Y is Y.
What's that?
Y is Y the exit.
So,
I'm just.
oh, okay. I was about to say, there's actually no exponents here except for these little guys, but we'll talk about those in a bit. This little number down here is not an exponent. It's called a subscript, and it just is like a label. So this is my x1. This is my y1. So that's my first point. Give me a thumbs up if you see how we labeled those x1 and y1, and that makes sense. Literally the first point, every point has an x and a y, x1, y1, first point's x, first point's y, right? 6, 8 is my second point. Between 6 and 8, which of those numbers is my x coordinate? 6, because once again, x comes before y. So I'm going to label this 6 as x what? 2. Which means I'm going to label the 8 as what? y2. So far, so good?
Yeah, I don't get it.
Okay, so right now, honestly, one of the hardest parts of this is the labeling. So if that makes sense, great, you're in a good spot. The first point has x1, y1. Second point has x2, y2. So when we go through these problems today, tomorrow, and next week, I'm going to ask what's the first thing that we do. The first thing that we do is label our coordinates. Because now what I have here, this complicated equation, is like a puzzle. Now, it's a puzzle that only has 4 pieces. So if I gave you guys all a jigsaw puzzle that only had 4 pieces, would it be pretty easy to figure out, or you think kind of difficult?
What are we so easy?
Really easy, right? It's just 4 pieces, 4 corners. I can figure out where they all go. So this process is actually just as easy. All right? My first point was pink, x1, y1. My second point was yellow. And we're using the exact same formula every time. This is not a formula you have to memorize, because you can use these notes on the test, and the distance formula is right up there on the wall. So even if you don't have a notebook, you can use that if we're taking a test or something like that. So now I have 4 puzzle pieces, and I have 4 slots for those pieces to go. I just got to put them all in the right place, right? If I've labeled them correctly, like we did, putting them in the right place should be fairly easy. x2 is my first spot. What am I going to put in place of x2? 6. Where'd you get 6? Right there. Yeah, that's what we labeled it. It's the second x value in my question. 6. Well, what's the first x value in this question? Everybody, what is x1? What do we label as x1? 3. So that's going to get plugged in right there.
You did it wrong.
I did it wrong?
Yeah, isn't 3 supposed to go right there? It's the first one.
x2 minus x1 is 6 minus 3. Yeah, so it's weird. You would think 1 would go first, but it's backwards. Okay? Oops. Who asked to go after Matthew again? Layla? Okay, go ahead, Layla.
Why are you trying to play that?
Play what?
Silly trick on the thing.
All right, my other 2 puzzle pieces. What is my y2? 8. And what's my y1? 4. That's the hard part. So if that seems easy, that's great. If it seems challenging, I understand. Yeah, what's up?
How'd you get 6 and 3?
Okay, 6 and 3, right? I'm always going to be given. Okay, perfect. Thank you, Emerson. So now I'm just going to do PEMDAS, right? What's the first letter in PEMDAS tell me to do? Parentheses. So I'm going to solve anything inside parentheses. Well, I've got something right here. What is 6 minus 3? Very quick. You must have been practicing. 6 minus 3 gives me 3. What does 8 minus 4 give me?
4.
Ah, okay. 8 minus 4 gives me 4. All right, I took care of the P. What's the E in PEMDAS stand for?
Exponents.
Exponents. So now I'm going to apply these exponents, right? What is 3 squared? 9. And what is 4 squared? 16. Again, like I said at the beginning of the week, if we memorize our perfect squares, it makes our life easier. If I know what these numbers are squared, I don't have to look at my perfect square chart. I could just come up with it right away, right?
It's going to be 25.
Okay, there's nothing to multiply. There's nothing to divide. Is there anything to add together? Yeah. What's 9 plus 16?
How you get 9 and 16?
Good. Hold on. Hey, whoa. Stop. I appreciate you asking. Because I guarantee you there's someone that's too afraid to ask that is also wondering the same thing. Are you cool with how we plugged all these numbers in? The 4 pieces? Okay. Now we're just, in the parentheses, we're doing what it says, which is subtraction. 6 minus 3 gives me 3. 8 minus 4 gives me 4. Okay? Now what's it telling me to do? Well, it's telling me to take 3 and square it. Well, 3 squared is 3 times 3, which is 9.
So there'll be 4 times 4.
Which is, there you go, exactly. That's how we get the 9 and the 16.
I got it.
Great question. I appreciate you asking that, truly. Yeah, no, like I said, I appreciate you asking.
That's not like
What is 9 plus 16 going to give me then? 25.
plus or minus 25, but at the bottom it says 50.
Good. I'm glad that you mentioned that. We'll get to that in a second. Okay. So we add those together. Now we have d, or the distance, equaling the square root of 25. Is 25 a perfect square? Yes, it is. What is the square root of 25? 5. So this is like a multi-step process.
It's not that hard.
Okay, there's a church.
Yes.
The last thing.
I know. Please.
25.
Okay. Okay, good. Take a look, right? The way that this equation is set up, where is it? Right here. It's got all kinds of operations. It's got subtraction, it's got an exponent of 2, and it's got addition. Then it's got more subtraction and another exponent of 2. So it's kind of a lot to take in. If we just follow PEMDAS always tells me what order I need to do it in. We did the parentheses, right? 6 minus 3, 8 minus 4. E is exponents. 3 squared is 9. 4 squared is 16. Now all I'm left with is 9 with a plus in the middle, and that's 16, right? Well, the next letter is M, nothing to multiply. The next letter is D, nothing to divide. The next letter is A. Hey, look, there's an addition sign right there. 9 plus 16 gives me 25.
And then if I get like 5, which is like the multiplication of.
Good, yeah. So this is like what we did with the factor trees. But because I know, hey, 25 is one of my perfect squares, if I take the square root of 25, that's just equal to 5. Because it's 5 times 5. There's my pair. Bring it out. Right? Nothing left over.
So whatever our answer is, we can chart and see what it. Okay.
Yeah, if it's a perfect square, we can use our chart to figure out what it is. It's not always going to be a perfect square. If it's not a perfect square, we're just doing this process right here to simplify it, which I know we're all confident with. I've seen it. This part should be good to go, and we'll see that when we get to the worksheet. So the distance between these 2 points is 5 units. Anytime we're talking about distance, I want to include units on the end.
Will it say miles?
Sometimes it will. If we're talking about a specific problem, yeah, it'll talk about miles and stuff, and then you just change out units to whatever the units are they give you. Now, should my answer be plus or minus 5 or just 5?
We don't need it.
Just 5. If you read down here on the bottom, we don't need a plus or minus sign because distance can't be negative. Distance cannot be negative, right?
Unless you're going backwards.
Let's say here's the map of your little neighborhood, right? And I'm standing right here in the middle of the neighborhood, okay? If I go 1 mile in this direction, or if I go 1 mile in this direction, are either of those distances me going negative 1 miles? No, that wouldn't make sense because distance has a length and a direction. Whether I go 1 mile to the east or 1 mile to the west, neither of those are negative 1 mile. It's just 1 mile in a different direction, right? So these are all the same distances. They just have a different direction to them. So whenever I'm solving for distance, I don't need a plus or minus, and I will definitely never have a minus. It'll always be positive, specifically when we're talking about distance. Go ahead and highlight that at the bottom just so we don't forget. You can highlight as much as you want. Yeah, and I know. Sure. Sophie, when she comes back. Okay, lots of great questions. I really appreciate them, right, for real. Are there any questions, other questions I can answer about this?
No.
Okay.
We just do more.
Yeah, we're gonna get started, but I'm gonna go through the first problem with you guys. At least the first problem.
I made it. No, you don't know, bro. You get a Hey, you guys want to use this?
Bro.
You guys want to?
Yeah.
Okay, bad.
I need a paper.
I don't think the line.
I need a paper. Sir, I need a paper. Yeah, but I need a paper. I don't have one. I dare
Let me go over this formula. All right, so everyone look at number one. Everyone looking at number one, right? Okay, number two. I'm going to let you do number one. I'm going to do number two because we're going to get a interesting answer. What's the first thing that I would like to do, or that I need to do?
I would label.
Label.
Label, dude.
3, negative 3. Is that my first point or my second point? What?
That's the first point.
First point. How do I know it's the first point? Because it's written first, right? First point. What can I label positive 3 as if that's my first point? X1. How do I know it's X1 and not Y1? Because X comes before Y. Okay? What can I label negative 3 as then? Y1. How about 2? X2. Because it's my second point's X coordinate. And what can I label negative 4? Y2. Every single question is going to be labeled just like this. X1, Y1, X2, Y2, X1, Y1, X2, Y2. Every single time. Yeah.
There's no X1s right here?
What do you mean?
X1.
We haven't written the formula yet. These are just the points. Okay? Now we're going to write the formula. D is equal to the big old square root of x2 minus x1 squared plus y2 minus y1 squared.
Do you have to do that, or can you just jump straight into doing?
You can write this up at the very top and then just plug them in as you go. You don't have to write the formula every single time. But at least write it up at the top or have your notebook out so you don't forget. Okay, this is important. I want everyone to do exactly what I'm doing. When we're setting this up, again, you don't have to write this formula every time. I'm going to rewrite this whole thing exactly how I see it, just with no variables. So parenthesis, space, minus, space, parenthesis, squared, plus, parenthesis, space, minus, space, parenthesis, squared. Again, I'm setting up my 4-piece puzzle to make it as easy as possible for me. And because I have negative numbers in here, I have to be very, very careful about my double negatives if I have them, okay? Everybody with me up to this point? Okay, let's build our puzzle. X2 is my first slot. What goes in X2's place? 2. X2 is positive 2. What's going to go in my x1 space? Positive 3. So my first quantity says 2 minus 3. Okay? Everybody still with me? Okay. What am I going to put in place of the y2 variable? Negative 4. And what am I going to put in place of y1? Negative 3.
Oh, we're doing a different problem.
We're doing number 2, sir. Yeah. What do I have right here when I plug that negative 3 in? What do I see? I see double negatives right next to each other. What do those two negative signs make? A big old positive. That's why it's important for me to write the whole equation with the spaces, and those minus signs in there. Because I guarantee you, a very common mistake you're going to make is negative 4 minus 3, when it should be negative 4 minus negative 3. You see what I'm saying? Okay. Now we're going to go through and solve following PEMDAS step by step. I still have my square root. I still have my quantities being squared. But now I'm going to solve inside the parentheses first. What is 2 minus 3? Negative 1. And what is negative 4 plus 3? Negative 1. Zach, can you please? Thank you. Everybody with that? I'm going to try and go as slow as I can. Now I'm going to do the e, the exponents. So my distance is the square root of, what is negative 1 squared? Well, that's negative 1 times negative 1, which is positive 1, plus negative 1 squared, which is the same exact thing, giving me positive 1. Sound good? Okay, what do I want to do now? Add them. What is 1 plus 1? So you may look at that and go, oh, my distance is 2. Is that correct? No. My distance is the square root of 2, which is very different, right? Can I simplify the square root of 2? If I do a factor tree for 2, is that going to help me at all? No. So that's my answer. D is equal to the square root of 2. What do I need on the end, though? Units. We don't want a plus or minus because distance cannot be negative. I want units instead. Question.
It's gonna be 1.
What's that?
It's gonna be 1. Oh no, 1.
The square root of 1 would be 1. The square root of 2 is somewhere between 1 and 2, as we know from our estimating. If I take 2 and I take the square root, it's like 1.41. We're just going to leave it as its exact answer, square root of 2. Sometimes you'll get something like the square root of 20, where you can bring out a pair of 2's and leave a 5 behind. You still want to simplify it if you can simplify it. Yeah, I'll ask for a question. Good question. This negative 1 here, I need to square it. Right? So when I'm squaring something, I'm multiplying it by itself. Well, if it's negative 1, then I'm doing negative 1 times negative 1, which is what? There we go. That's how we got the positive 1. And it's the same thing over here, so I get another positive 1. Yeah. Does that sound okay? Quick show of thumbs. How does that sound? Thumbs up. Sounds pretty solid. Thumbs sideways. Sounds not so solid. Thumbs down. No idea. Okay. Hi there. Sure. Alicia.